All right, so we're going to be looking at K6 SSS theorem in coordinate plane. So we're going to use the distance formula. We're going to measure the different sides, maybe even count. Sometimes we can just visually count. So we have two triangles here, and we're going to determine if these two triangles are congruent. Now, if you look at them, it's a rotation of 9 degrees happening. So this blue triangle is going to rotate up here to there. So I'm going to have to measure D to E. I'm going to measure W to X. So W to X, if I just go left to right, it's between 8. Let me get the little marker out. From 8 to 4 right there. So that's going to be 12 different spaces. Okay. And then going from here, if I count up and down, I'm starting at 4 and going all the way to negative 8, which is going to be 12 as well. And then E to F right here is from 10 down to 1, so that's going to be 9. And then from here, this is 1 to 10, so it's also 9 right there. Okay, so this is going to be considered congruent. Okay, same thing, let's take a look at this. So this is going to be SR is going to be the same as FE. And also, if you look here, so it's QRS. So RS is going to be the same as EF. So EF is going from negative 9 to 2. So that's going to be 11 spaces. And then from here, S to R, this is from negative 2 to 9. So that's going to be 11 spaces as well. If I'm looking here across here, this is 9 to 0. So that's going to be 9. This is from 1 to 10. That's going to be 9 as well. So these are also going to be congruent. Let me jump ahead a little bit, see if we get a little bit harder one. Okay, so PQR and IJK. So JK should be the same as QR. So QRJK, we can count that one as well. So from 10 down to 1, that's going to be 9. And Q to R right here is from 1 to 10, so that's going to be 9 as well. These diagonals, we're going to have to use the distance formula. Let's try one more side here, make sure that they're lined up. So if we look at IJ right here, we're going to start at this point right there, and we're going to measure to this point right there. So if we use a distance formula is going to be x2 minus x1. Let me just pause, and I'm going to write this out for you. All right, so I wrote out all these steps. So starting out with this one right here, I inputted my coordinates for I right here. My x in this case was 6. My y is going to be 6 as well. So those are the 6s there and there. And then my my j coordinates I put there as well. So my x for my j is going to be at negative 1. So you have minus and minus, which is going to be a plus right here. So that the first part is going to be 6 plus 1 is 7, and we're going to square that. And then for the other part of 6 minus 10 is going to be negative 4. Negative 4 squared is 16. And then when I simplify that down, it's to the square root of 65. Now I can solve for the square root, or I can stay there. So as long as once I find the distance formula, which I did down here, I did all these steps and I ended up getting the same number. So I got the square root of 65 for j to I. I also did it for q to p. So that distance formula is going to be the same there. So that length of that diagonal side right there is going to be the same as well. So this is what you're going to have to do for each of these. If you don't have a straight line, either going straight up and down or left to right, where we can just count. So when you have to go diagonal like that, we can use this distance formula. And if they match up, they're the same, then these sides are going to be congruent and the triangles are going to be congruent. So these are both going to be yeses. All right, so that is for K6.